This is a Velleman Strobe circuit, or was, along with a Bedini circuit. So this is a solid-state Bedini oscillator using the bottom coil, this chip, and this circuitry here. Input is 24 volts DC from mains. Runs through here. Output from the SG charges up this capacity. This capacity acts as source for the modified Strobe circuit here. I ended up having to pull almost all of the connections external to the term strips to be able to use higher rated devices and allow for customization. But what's ultimately gone on here is that it's ultimately a default circuit, barring the capacities being higher rated, and also on both sides of the actual strobe tube, the flash tube, which is down there that you can't see real well because of some of this other stuff in the way, but right, there's the flash tube down there. On one side of the tube it comes out and it actually goes through this top inductor, which is a trifilar 18 gauge half pound per strand coil from an old SG that has all 3 strands set up in series, so they're all wired in series that come out and then go into the strobe. But in parallel I have to have a 5UF AC run cap, which is connected only over the coil, only over this coil, which is 3 strands in series. And this is in series with then the strobe lamp. Let me show you the difference of the functionality here in terms of having the capacity over the coil or just having the coil alone. So we'll start it up, it's going to start running, and it's got the coil and the capacity in place. Then I'll disconnect the capacity with this one lead here. You'll note a change in the pulse rate there, and it'll be a much more strong pulse per each pulse as opposed to a bunch of small high-speed flashes. So let's go. Powering here. Alright, can't really pick it up, it's flashing fast enough, right? Alright, and then we pull the capacity off of being in parallel with that coil, which is in series with the strobe. You hear it? You see it? It's dropped to a much slower pulse rate just by removing that capacity, and that capacity had to be tuned or tried multiple different capacitors in that place to find one that gave me a decent result. And you can kind of see here, if I connect it up, you see these arcs. That's a lot like what you see on the Blarian device when you short 2 windings of the primary together. But once that connects back up, everything's back in series and everything wants to run like it is. So this might, I'm sharing all this because this might be how the gapped exciter works. With the problem being that this capacity and the inductance need to be to one side of the spark gap. So the spark gap in this case is the xenon tube, which is in series with the LC. So instead of them all being in parallel, it might be that the spark gap needs to be in series, but I'm just sharing that as a potential idea because I've observed it here and it occurred to me that it might apply there on the QEG spark gap exciter thing. Anyways, there you go. That's another nice side effect, is you can turn it off and it'll stay on and do a few extra pulses after.